So this first three problems, you have to write the equation of the line, which means you're going to have to find each slope, and then also interpret what the slope means. So for number one, and I have the slope formula written over there to the side, so your slope is going to be 30 minus 15, the difference of the two y values, over 6 minus 1. So 15 over 5 reduces to 3. And then we plug into the equation y equals mx plus b. So you can choose any point you want. I'm going to choose 115. So the y value is 15. Your slope is 3. So that's y equals m times the x value. And then solve for b. So if I subtract 3 from both sides, we get that b is going to be 12. And then putting it all together, the equation is y equals 3x plus 12. And then what does that mean? A child grows, it's based on the slope, so it grows 3 inches per month. All right, so that's number one. Number two, again, we have to find the slope. So 600 minus 200 over 1 minus 5. Notice you're going to get a negative slope because the line is going in a negative direction. So this will give me 400 over a negative 4. So your slope is going to be a negative 100. And we do the same process again. Choose a point. I'm going to choose the one 600. So we have the y value is 600 equals your slope times the x value plus b. So I'm adding 600 to the other side, so that means b is going to equal 700. So your equation is going to be a negative 100x plus 700. And what does that mean? Every year home phone sales decrease. So I'm just going to abbreviate this. Phone sales will decrease by 100 million, because you want to do in millions, decrease 100 million per year. And then this last equation, notice this is just a constant. So you don't have to find the slope because your slope is 0. So the equation of a constant is always just y equals whatever that constant is. In this case, it's 3. And that just means that you are walking, since this is what this relates to, the speed of your walking at a constant rate of 3 miles per hour. All right, so there's your 3 different linear equations. Now you're going to be solving a 3 by 3. So the first thing you want to look for is what to eliminate. So notice, I always again like to label my 3 equations. Notice this last equation has no y value, so that's kind of a gift. That means I want to eliminate my y value in the first 2 equations so that I have 2 equations and 2 unknowns. In order to eliminate my y, I'm going to have to multiply this one by 2 and this one by 3. That way I'll have a negative 6y and a positive 6y in the y value, so they'll cancel. All right, so let's do this. So we have 6x minus 6y plus 2z equals 20. So make sure you multiply all the way through. And this one will become 9x plus 6y minus 9z equals negative 6. And so we add those two together. That gives me 15x, my y's go away, minus 7z equals 14. So now I have 2 equations in the same 2 unknowns, and I want to somehow join those together. So since my x's are opposite signs, I'm going to eliminate x, but in order to do that, I'm going to multiply everything in this equation by 5 and write it down below this other one. So we have negative 15x plus 5z equals negative 10. So we can add those together. So when you add them together, the x's go away. We have, I'm going to write the answer up here, we have a negative 2z equals 4, which tells me that z will be a negative 2. So once you get that first variable, the rest is just going to be back substitution. So I can back substitute. I'm going to substitute into this equation z because it only has an x and a z. So I know negative 3x plus my negative 2, which is my new z, equals negative 2. So negative 3x equals 0, which means x equals 0. That's totally a legitimate answer. And now I have x, I have z. So I'm going to substitute it somewhere where I have a y value. So I'm going to go back to my equation A. So I know that x is 0 minus 3 times y, that's what I'm trying to solve for, minus 2, which is your z value, equals 10. So this tells me that negative 3y equals 12, adding 2 to both sides, so that y is going to be a negative 4. And then you want to write your final solution as an ordered pair. So x, y, z, 0, negative 4, negative 2. That is going to be your final solution. Okay? On number 5, so we're going to go through this one. I am going to eliminate x. You always want to kind of decide what to eliminate first and stick with that strategy. So again, we have the 3 equations, A, B, and C. So if I want to eliminate x, the first thing I'm going to do is add a plus c. And I don't have to do anything because the x's will automatically cancel. Negative y plus a negative y, I'll have a negative 2y. Negative 2z plus z is minus z. And then 9 plus 5 gives me 14. So now I have to bring in b because I haven't used b at all. So what I'm going to do is multiply everything in C by 2, and I'm going to add b plus 2c. So this I'm going to multiply by 2, multiply by 2, multiply by 2, that's going to make that a 10. So what we have here, so then I'm adding b plus 2c. So when I add those, my x's go away. Amazingly enough, so do my y values, which is a real gift. And then, so do my z values. So I basically get 0 equals 2, which 0 never equals 2. So voila, you have no solution, and you're done. You don't have to do anything more. So whenever you get 0 equals something other than 0, if I got 0 equals 0, that would be infinite solutions. But 0 never equals 2, so you're done. Okay. So now we do the, this is actually going to be a system of 3x3s as well. And you're going to have another one on this where each time you're going to have a quantity for an equation, you're going to have a value for your equation, and you're going to have a relationship for your equation. So we have a 9-pound mixture of trail mix. So that's going to be the total quantity that we want. So we're going to let x equal raisins. We're going to let y equal the sunflower seeds. And we're going to let z is going to equal the chocolate-covered peanuts. Okay? So when we do this, we know that if you add them all together, x plus y plus z, just as a physical quantity, you're going to have a total of 9 pounds. So the quantity is without any value. The value now comes in with the cost. So raisins are $2 a pound, so 2 times x. The sunflower seeds are $1 a pound, so I can just leave this as plus y. And chocolate-covered peanuts are $1.50 times z. And then the total value is going to be $14.50. And then the last one is the relationship they always give you, where they tell you that you have twice as many raisins as sunflower seeds. So be careful because you're trying to make this equal. So we have more raisins than sunflower seeds. So if I want those two quantities to be equal, then I'm going to have to double my sunflower seed so that it equals my raisins. And if you're not sure, plug in some numbers so you can make sure, because it is, you have more raisins, but you want to set these two things equal. So you have to double the other one to make them equal. Now with these kind of equations, I would do substitution. So wherever I see an x, I am going to substitute 2y, so that then I have two equations just in y and z. So in this first, in the quantity equation, kind of give them an ABC, 2y plus y is going to give me 3y plus z equals 9. And when I substitute it in the second one, so 2 times 2y, that's 4y plus y. So I have 5y plus 1.5z equals 1450. Okay, so at this point we want to figure out how to solve this. Who do we want to get rid of? I am going to, and there's many ways we can go about this, I'm going to multiply the top one by 5, I guess, and the bottom one by -3. So I think that's what I'll do. So I'll multiply this one by 5, and this one's going to get multiplied by a -3. And I'm going to write the answers down below here. So this one will become 15y plus 5z equals 45. The bottom one will become -15y plus 1.5 times 3, 4.5z, and 1450 times 3. Oh, sorry about that. It's also a negative, so I needed to make that. This b is going to be a negative, equals a -43.5. Okay, so then my y's cancel. I've got 5 minus, so this becomes 0.5z equals 45 minus your 43.5 is 1.5. So we can solve for z, and that's going to give us 3 pounds, since z represents chocolate-covered peanuts. So this will be z will equal 3. Now we can start to back substitute. So I'm going to go back to this equation right here. I just want an equation that has y and z, no x in it. So 3y plus 3 equals 9. So 3y equals 6. So we know that y is going to equal 2. And going back to my equation C, if y is 2, that means x is going to be 6. So you're going to have 6 pounds of raisins, 2 pounds of sunflower seeds, and 3 pounds of chocolate-covered peanuts. That would be your solution. Okay, this last problem, you're going to have a couple of these where you compare a given equation, or actually you're just going to come up with the equation from the data and then find out the amount of fuel left in your tank after driving for 90 minutes. So we'll be plugging in x equals 90 at some point. All right, so let's first come up with our equation. So notice that this is plus 20, plus 20, plus 20. This is minus 2, minus 2, minus 2. So that tells us this is a linear equation because you have a constant rate of change from the top and the bottom. The ratio is the same. The slope, be careful of this, the slope is the rise, the y values over the x values. So it's -2 over 20, which is a -1/10. And since they gave you x equals 0, they actually gave you your y-intercept. That's always kind of a gift. So we know the equation is going to be y equals -1/10 x plus 18. And now all we have to do is plug in what is y when x is 90. So we plug in 90 here plus 18. So that's going to give me -9 plus 18 is 9 gallons. So in 90 minutes, you're only going to have 9 gallons in your tank. Okay, so now we're going to do some transformation work. So translating 3 units up. So that's a vertical transformation. Whenever you're doing something vertical, it goes outside of the parentheses. 3 units up is like you're adding 3 to f of x. So if I'm gonna kind of show the whole process. So if I'm doing 3 times f of x, it's 3 times, and now we substitute our whole f of x. I'm sorry, I totally went off on a different tangent there. We're just adding 3 to our equation. So we're gonna go negative 3x plus 1 minus 4. That's your f of x, and then we add 3 to it. So we can combine these last two equations. Negative 3x plus 1, negative 4 plus 3 is a minus 1. That's your final answer, so we call that g of x. So again, anything vertical goes outside the function, outside the parentheses. Anything horizontal is going to go inside, and it reads the opposite, remember? Anything inside is going to be horizontal, goes inside the parentheses, substitutes just for x, and works the opposite. And then we're going to follow that by a translation 3 units down. Okay, so what we're going to do first is it's going to be f of 2x, because a shrink by a half inside the parentheses, it reads the opposite of what you're doing. So you would actually shrink it by a half, but we read it as 2x in parentheses. So that substitutes actually for the x. So instead of x now, I've got 2x here. And then 3 units down is outside the parentheses, so that goes outside as minus 3. So we have a function g of x, which equals the absolute value of 2x minus 3. All right, so then we have, again, we are going to compare profits from, if this person has selling t-shirts, 4/3 x minus 20 represents their profit. They are going to be doubling their profit. So what they're going to do is 2 times f of x. So notice that goes on the outside because it's like a vertical dilation. You're doubling the f of x, which means I have to then substitute in here 4/3 x minus 20. When we work that out, that's 8/3 x minus 40. That's going to be your new profit equation. And it wants to know what's the profit when you are selling 300 shirts. So we plug in 300 and simplify this out. So that would be 100. So we have 800 minus 40, which is going to be $760 would be your new profit. All right, next problem. Now this is like the one that's going to be coming up where you are given an equation and you're given some data and you want to compare. So this is the prom. One is going to Sunview, one plan goes to Lakeside. Which venue charges more per student? So that means for Lakeside, we need to find the slope and the equation. So the slope is going to be 1,800 minus 1,500 over 125 minus 100. So we have 300 over 25, and that simplifies out to 12. All right, so I'm going to show my work down here. I'm cramming it into that tiny little space. So for Lakeside, you have a slope of 12, so we have to come up with the whole equation. So I'm going to use this first equation. We know that 1,500 equals your slope times 100 plus b, so 1,200. So when you subtract 1,200 from 15, you get that b equals 300. So Lakeside equation is y equals 12x plus 300. So what that means is Sunview is charging $10 per. Whenever it's per, you're comparing slope because that's a rate of change. So $10 per student versus the $12 per student. So that means Lakeside charges actually $2 more per student. And then they wanted to know how many students in order for the two costs to be equal. So that means we're going to set the two equations equal to each other. So 10x plus 600 equals 12x plus 300, so subtract 10x from that side, 300 from this side, so it's going to take 150 students in order for the two venues to be the same cost. All right? Now this last one, it asks you, number 12 rather, asks you to graph. So this is your absolute value graph. So the parent function, I'm going to draw the parent function in green, is just the v. So x equals y going in that direction, x equals, or y equals the negative x going in that direction. So that's your parent function. So what is happening to this parent function? Well, x minus 2, it's in the bracket, so that's horizontal. And it has a minus, which means it's going to, inside always works the opposite. So you're going to go in the positive direction, right 2 units. Outside is the plus 4, so that means you're going to go up 4 units. So I'm going to just take the vertex and go over 2, 1, 2, 3, up 4. You have no dilation to it, so it's still just right through the middle, 1 over 1, up 1, over 1, up 1. That would be your final graph. So you'd have a new vertex at 2, 4. All right, so now we're still doing reflections now in the y-axis. So if you're reflecting over the y-axis, notice that that's a horizontal reflection. So that means all your f of x's becomes f of negative x. Anything horizontal stays in the parenthesis and only substitutes for x. So I take my original function, which is here, and I'm going to substitute just my x value with a negative x, and that would be your final equation. Now I'm not sure what your teacher expects. You can actually simplify this, because I can factor out a negative 1 from both terms, and the absolute value of negative 1 is 1. So this actually would turn into this equation. Both of these are correct. They just, one is maybe more simplified, and I don't know how picky your teacher will be about that. Okay, so number 14. Translate 4 units down. That's vertical, so it happens outside. So that's like saying f of x minus 4. So we have our f of x, which is this, and then we are going to subtract 4 from that. So putting it all together, 3 times x, 1 minus 4 minus 3. That will be your new function. All right, and this last one, vertical stretch by a factor of 3 followed by 2 units up. So again, order matters how you do these. So the vertical stretch, that's vertical, so it goes outside. So that's going to be 3 times f of x. So you can never distribute inside an absolute value sign. It just sits out in front as 3 times whatever the f of x was. If you had something added at the end, you'd have to distribute to everything. Then followed by 2 units up, which is also vertical, so that's going to also be outside the function. So all we're going to do is add 2 at the end, and that will be your new g of x function. Okay, so here's another 3 by 3 word problem, and it's going to have the same, so you're going to have a quantity, you're going to have a value, and you're going to have a relationship equation. All right, so this is about number of tickets being sold. We're going to let x equal the reserved, and y is going to equal the field level, and z will equal the box seats. So when we read it through, how many total physical tickets? You have 10 tickets. So that means x plus y, so the reserve plus the field plus the box tickets, that's a total of 10 tickets in your hand. That's a quantity. Then we have the value. The value is how much each ticket is worth. So the reserved are 20, so that's going to be 20x. The field tickets are 50, and your box tickets are going to be 100, and that total cost comes to 370. So this all has the values on it. Then we have the last one, the relationship. You have twice as many reserved, which was our x, as field, which is our y. So again, we have more reserved tickets But if I want to make these equal, that means I have to double the field level so that it equals the reserved, because now I'm setting that relationship equal. So in other words, if I had 5 field level, that would give me 10 reserved, which makes sense. Okay, so in these kind of problems, always just do it as substitution. So wherever I see an x, I am now going to substitute 2y into that. And so then I'd have just an equation in y and z. So in this first equation, the quantity, this becomes 2y plus y, so I'll have 3y plus z equals 10. Here, 20 times 2y, that's going to be 40y plus 50y, so I have 90y plus 100z equals 370. And I'm going to knock off a 0 on each of these. It's like dividing by 10. And so to combine these two equations, I'm going to take this one and I'm going to multiply everything by -3, so that I have a -9y minus 3z equals -30. And I can then add these two equations together. So the y's will go away. I have 7z equals, so 37 minus 30 is 7. So z equals 1. We have one box seat, so z equals 1. And now we can start to just back substitute. So if z is 1, I'm going to substitute it up here. That means we have 3y equals 9, subtract 1. So y will be 3. So we have 3 reserved, or sorry, field level. 3 is the field level. So 3 of those. And then probably the easiest, I'm going to go back here. So I have 3 of these, which means that I have 6 reserved. So if you had to write it as an ordered pair, it would look like this, or you could write it out that you have 6 reserved, 3 field tickets, and 1 box ticket. Okay, last problem is kind of like the other linear one where you were given, in this case we're comparing babysitting costs. So one person has $10 flat fee plus $6 per hour. Anytime you see per something, that's your slope. So for Kelly, her equation is going to be y equals 6x plus 10. So in other words, if she didn't work any hours, it would be a $10 flat fee and then $6 per hour after that. For Kim, we have to use the data they give us in the table. So I wrote it out here. So first thing we have to do is figure out slope. I'm going to use these first 2 points. So her slope is going to be 26 minus 22 over 2 minus 1. So she charges $4 per hour. That's her slope. And then we have to figure out the y-intercept, so we do the y equals mx plus b. 22 equals 4 times 1 plus b, so that tells me that b is going to be 18. So Kim's equation is y equals 4x plus 18. So who charges more per hour? So Kelly charges $2 more per hour, since she charges $6. And how many hours would they both have to babysit for the cost to be the same? That means we're setting these two equations equal to each other and solve for x, which represents the hours. So subtract 4x from both sides, subtract 10 from both sides. So after 4 hours, the costs would be the same.